Okay, to solve this equation, we're going to need to multiply both sides of the equal sign times the least common multiple of all the denominators, which is the product of all the denominators in this case, 4 times v times 2v minus 3. Sometimes to have to write a little bit less here, we can just multiply the whole equation times 4v times 2v minus 3. The whole equation times that. Let me make this a little more prominent here. So what we're going to do is distribute this factor to each term in the entire equation. So this whole factor distributes to each term in the equation. When it comes over here to the far left term, the 4's cancel, so you're left with negative 3 times v times 2v minus 3. So negative 3 times v times 2v minus 3. Then the second term here, when this factor on the right distributes there, the v's cancel out. So you've got 5 times 4 is 20 times 2v minus 3. So it's plus 20 times 2v minus 3. On the right side of the equal sign, the 2v minus 3 cancels, so you're left with v times 4v, or 4v squared. So there's our first step. Getting rid of the denominators, canceling out all of the denominators. Now, we take this negative 3v and distribute it through the parentheses here, and the 20 through these parentheses. And we end up with negative 6v squared plus 9v's plus 40v's minus 60 equals 4v squared. Now let's get all the v squareds together on the same side of the equal sign by taking 4v squareds away from both sides. Combine the two middle terms here, and we end up with negative 10v squared plus 49v minus 60 equals 0. That's a quadratic equation, and we'll have to factor that to find our solutions. But first, let's get rid of this negative in the leading coefficient by multiplying both sides by negative 1. This makes the leading coefficient positive. So it changes the sign of every term. So the negative times the negative makes a positive, negative times a positive makes a negative, and negative times a negative makes a positive. So we have to factor this polynomial, and here's what we get. After we finish this solution, I'll go back and show you how that factored exactly. But in any case, it's 2v minus 5 times 5v minus 12. So that can equal 0 if either of those two factors is itself equal to 0. So in this case, if v is equal to 5 divided by 2, the 2's would cancel, and then you'd have 5 minus 5, which is 0. Or this one gives you, if v is equal to 12 divided by 5, and you plug it in here, the 5's will cancel, and you're left with 12 minus 12. So these are our two solutions to this equation. And notice that neither of them makes any of the original denominators come out to be 0. So they're both valid solutions. Now, this was a big step. So I want to explain how I got from here to here in a little bit more fully. So if you're happy with this, you're done. Otherwise, I'll show you how to get this factorization. So that's the last bit I want to show you here. We have the polynomial 10v squared minus 49v plus 60 equaling 0. And we want to factor that polynomial. So, multiplying the two n numbers together, you have 10 times 60. That's 600, but we're looking for two numbers that have a product of that. But a difference, or a sum rather here, that's a plus, so the sum is equal to 49. So we have to see how to split up those factors, the factors of our product here, so that the sum of the two resulting numbers is 49. Well, let's look at the factors a little more closely here. 10 is 2 times 5, and 60 is 6 times 10, which is 2 times 3, that's 6, times 10, which is another 2 times 5. So this is equal to 2 to the third power times 3 times 5 squared. That's the prime factorization. We have to split up these factors into two numbers so that their sum is 49. First of all, that's an odd number. Nothing strange about it, it just happens to be odd rather than even. So, the 2's have to all stay together, because if they were split up, if both of these had a factor of 2, if you add two even numbers, you'll get an even number, and 49 isn't even. So let's put all the 2's together here, which becomes 8. So there's a factor of 8, and also notice that 49 is not divisible by 5, so the 5's have to also stay together. If a 5 goes in each, then this would be divisible by 5. So the 5's have to go together. Let's put it over here, 25. Now to get a sum of 49, well, the 3 will have to go with the 8. Then it's 24 plus 25, which equals 49. Okay, we found our numbers, the numbers we were seeking. 24 and 25. Now we rewrite the middle term up here using 24 and 25. So 10v squared minus 24v minus 25v plus 60. And factor by grouping will work to finish this off. So out of the first two factors, first two terms rather, you can factor out a 2v. 2v times 5v minus 12. Then you know it's a 5v minus 12 over here as well, to be the same as this for factor by grouping to work. So we had to factor out a negative 5. Negative 5 times 5v is negative 25v. Negative 5 times negative 12 is positive 60. So we can factor out the 5v minus 12, which leaves behind 2v minus 5. And there we have it. That's the factorization that led to our solving the problem. So it can take a little bit of work to get that. But once you have that factorization, you have the solution to your equation.